Good morning, all.
Good morning, sir.
So we have only 20 people, okay? So anyway, we will not wait for others. Anyway, I'm recording it. we'll start our class, okay? So in today's class, we are going to discuss about the some graphical method. Is it visible? Hope it is
Yes,
visible,
sir.
right?
Yes.
Yeah. So anyway, because if we keep on waiting for others, they may come after 10:50 also, okay? So we cannot finish our syllabus. So in such way, today we will see something about the graphical methods, that is Rebans and the Kalman's methods. Okay, so Reban has constructed this for active case. So gave the graphical solution for the determination of the total active pressure according to the Coulomb's theory. So according to Coulomb's theory, he has developed some graphical methods. Okay, so that method again he has taken this particular wall and delta, making angle delta and reverse. This is the active or pressure. Okay, this is the beta, and this is the phi. And what he has done is step by step procedure he has given, shows the graphical construction. Okay, the line BD is drawn at an angle phi to the horizontal. So first he has drawn the BD at an angle of phi. This is the phi dash. Okay, then the line BL drawn at an angle of psi. Okay, psi with BD. So BL, again this is the B and this is the L. Okay, so he has drawn this B and the L here, from here to here. Then what he says uh, is known as the earth pressure line. Okay, so this particular line is known as the earth pressure line. So this is earth pressure line. Then the psi is equal to the beta minus delta. This psi, how much you have to draw is nothing but the beta minus this delta. Okay, that much psi you have to take and draw this B into L. Okay, so this BD just he has taken imaginary BD uh, line drawn with the angle of phi he has drawn. Okay, a semicircle BMD is drawn on BD as diameter. BD as the diameter, BD as the diameter. Okay, and semicircle is drawn here, B into D, BMD. Okay, BMD. The line AH is drawn parallel to BL. The line AH is drawn parallel to BL. This is the BL. Okay, A into H. After drawing the semicircle, this is the A, this is the H, which is parallel to BL. Okay, and intersecting the line BD at H that we have seen. A perpendicular HM is drawn at H. HM is drawn at H, intersecting the semicircle at M. HM is drawn. Okay, H into this one more. This line is drawn, intersecting H. The semicircle H M. Okay. With B as the center and BM as the radius, B as the center, take the B as the center, BM as the radius. With B as the center, BM as the radius, an arc MF is drawn intersecting BD. Arc, this is MF is drawn intersecting this BD line. Okay, this arc is drawn. Then what he says, the line FE is drawn parallel to BL. Line FE, look at F, this is F, E is drawn parallel to this BL. Okay, sorry, the parallel to drawn parallel to BL only. Okay, intersecting at the E, it will intersect. Okay, so after drawing this arc, this point you will get it, draw one line. Then what he says, with F as the center and FE as the radius. F as the center, FE as the radius, an arc is drawn to intersect BD at N. FE as the radius, F as the center and FE as the radius. F as the center and FE as the radius. Okay, draw this arc intersecting here N. That's what it says. Okay. BD at N. The line B represent the critical failure line. The line BE. This line particular represents the critical failure line. So that's what we are interested in. Okay. So this particular line, whatever we get it, is the critical failure line. He says. Okay. So and total active pressure PA is given by. So what he says, the active pressure. Okay, the active pressure acting, it will not be whole. Okay, active pressure, what it says is uh, unit weight and the area of a triangle NEF, area of a triangle NEF. This triangle will give the active earth pressure. This particular triangle, the force, the whatever the it will act. Okay, that particular pressure is called the active earth pressure. And how we will get it? We can take the uh, triangle area half into base into height. Height is the x. You can, okay, x is the perpendicular distance. EG between EG. This is the x. If you take it half into base into height, so that particular small wedge portion that is given will be given an exact PA, that total active pressure. Okay, total active pressure, which acts on that. Okay, it will the whole wedge will not act. Okay, in the sense the actual active pressure how much it will act would be that area of that triangle. So there is the proof also given here. Okay, so you just go through a simple thing, triangle he has taken and so on. Then finally what I'm trying to tell, x and ml, like we have done last time, finally what he says is whatever value he gets is exactly like our Coulomb's theory. This half into k into gamma h square Ks. This is the Ka value. Okay, at the end this I am showing you. So this is the Ka. Same as the equation 19 by 33, 39 means same as the Coulomb's theory. So he has thought in different way in a graphical solution, and finally he has proved that this Ka is equal to the Coulomb's Ka. So that's what he has given the graphical solution. He has done in a different way. Okay, taking graphical solution, graphical way he has given. This Kalman's also construction by active or pressure. This fellow also, this Kalman's theory is uh, general than the great, better than this Ray-Bans. The Ray-Bans construction becomes inconvenient when the slope angle I approaches the phi. What he says, then phi equal I equal phi, the inclination, so it is inconvenient. Then Kalman's 1860 developed a method which is more general than the Ray-Bans method. It can be used to determine the Coulomb's earth pressure for ground surface of any configuration for various types of the surcharge load also. So here you can expect surcharge load also. And for a layered soil means now we are taking both the soil, cohesive soil and cohesionless soil, and differently. But the back side of the wall, if you have cohesive soil, cohesionless soil, sandy soil, gravel soil, layered soil also, this particular method can be used. That's what the Kuhlman says. Okay. So backfill can be of layered soil also. Not necessarily it should be clay soil or sandy soil or a seafy soil. Kuhlman's construction is in fact a method of construction of a forced triangle in a rotated orientation. The procedure follows here. So this is just have a look here. So what he has done is, this is the wall, this is the AB. Okay. So first what he has done is he has assumed the failure wedge. So just, yeah, now it is just we'll go through this. It's very, very interesting actually. What he says is uh, in different way. So from point B, look at that picture, okay? So these Rehbans and Kalman's method are graphical methods. Okay, just try to understand it. Okay, I don't think they will ask in the exam also, but try to understand what these Kalman's and this Rehbans theory is all about. Okay, which is better and how they have done procedure. Okay, so from point B, look at that point B. A line BD is drawn at an angle phi, exactly like previously. Okay, to a horizontal as a weight of the wedge is plotted along this line. Okay, so BD is drawn at angle phi or phi dash to a horizontal as the weight of the wedge is plotted along this line. Okay, it is also known as the weight line. That means it particular line is called the weight line because whole weight we are taking it. First BD we are drawing it with a phi with the horizontal. Okay, this particular line BD is called the weight line. A line BL is drawn like similar way. Okay, with the psi. A line BL is drawn at an angle xi with the line BD such that as previously we have taken psi equal beta minus delta, where beta is the angle which the back face makes with the horizontal and delta is the angle of friction here. This B and delta we are following from the Coulomb's theory, same thing. Okay, so this xi is drawn here, this particular BL. Both lines have been drawn, okay, with the angle we know and we have drawn it. Next step is a failure surface BF is assumed. That means what we do is we'll assume some failure surface, this BF here somewhere, BF this side and this side. What we'll do, keep on assuming it. Okay, first what we'll do is we assume that failure surface here. This is the weight line and this is the failure surface BF. And the weight of the wedge ABF is computed. Once we assume that failure, this one, we can compute it is a triangle, and once you know the unit weight, we can compute the ABF weight. Okay, the weight of the wedge is plotted along BD such that BP is equal W. Okay, the weight of the wedge, okay, in particular scale is plotted along BD, okay, such that BP, this is BP, BP is equal to weight. Understood? The weight of the wedge is plotted along BD such that, that means we'll assume it with weight, some suppose how many kgs are some kilonewton weight for this graphical. Okay, this much is for 10, 20, 30, 40, 50, like that. We divide it. Okay, and this BP is equal to weight. A line PQ is drawn from the point P parallel to BL, okay, to intersect the failure surface BF at Q. That line P and Q. This PQ represent the, sorry, is drawn parallel to BL. This is the BL, okay, parallel to BL to intersect a surface BF, here PF, this Q at Q. This Q is drawn. Understood? Just try to understand. Okay, it's a very simple thing. The length PQ represents the magnitude of PA. What he says, the length PQ, the length, this PQ represents the magnitude of PA required to maintain equilibrium for the assumed failure plane. We have assumed some failure plane, right? So is required to maintain equilibrium for the assumed failure plane. Like that, several other failure planes BF dash, BF double dash, and etc. are assumed. So here BF we have drawn. Okay, one more failure plane, one more failure plane, one more failure plane will draw, and this PQ one dash, PQ double dash, like that. We'll draw all these things. Okay. Then what we'll do is uh, the curve, a smooth curve is drawn joining that particular curve is known as the Kalman's line. This particular line is known as the Kalman's line. This is weight line and this is Kalman's line. Understood? Now what he says, the line dotted, okay, shown in dotted, is drawn tangent to the Kalman's line and parallel to the BD. Okay, one tangent we have to draw here, parallel to BD, a tangent of this curve. Point T is the point of tangent. Okay, the magnitude of the largest value P max of PA is measured from the tangent T to the line BD and parallel to BL. It is equal to Coulomb's active pressure. The maximum value we'll find out. This is called the P max. From where we have to measure, from where? From the T, the tangent. And this is Coleman's line. And this failure plane will assume it generally. Okay, so this particular line is called the Pmax. Understood? So the actual failure plane passes through the point T dotted. So dotted it is shown. Okay, so this is the actual failure plane, not this F. Okay, F dash we have assumed it, all these things. So this particular passes through the T, okay, which is the tangent we have drawn for the Coleman's line. So this particular failure plane called the actual failure plane. Actual failure plane. Understood? So here now this particular thing can be applicable for the effect of uniform surcharge or line load in the sense some point load if we have it, or along the line, okay, we have some load. The Kalman method can be easily extended to include the effect of uniform surcharge or line load. Okay, and what we do is each load is falls within the assumed failure rate is included by adding it to the weight of the failure. Okay, so suppose we have a line load here Q, then what happens, this Kalman's line will break because load is increasing here, right? So double both the things, we will draw it and we take the both the tangent. Okay, what it is given figure, this shows the modification when the line load Q dash acts on the backfield. The Kalman's line up to a point Q is similar to the case when there is no line load. Okay, however, at the point Q it becomes discontinuous as suddenly the load of the weight is increased due to the line of Q dash. In this case, the tangents are drawn to the two segments of the curve and the value of PA, the active work pressure, is determined. The value of PA plus delta PA is measured from the line BD, okay, to the maximum point on the Coleman's line, that includes the line load. So like that we can apply this particular Kalman's theory to the surcharge load. Surcharge load means some line load if we have it, okay, some pipe or maybe some concrete, something which is can be applied. Okay, and that's all with this Kalmans and the Raybans and this Coulomb theory. You can go through it. Okay, so Coulomb theory we have seen for a cohesive cell how we can use this Coulomb's theory. Again, the force triangle we have to draw. Okay, the Coulomb's weight theory can be extended to cohesive cell. Okay, in addition to three forces, the previously what we have seen, considered for the cohesionless soil in the preceding section. There are two more forces, namely one is the cohesive force C, okay, this one failure plane, along the failure plane B, and adhesive force CA here, okay, will act. And same manner we can do this if you know these angles and the uh, values, okay, few values, and we can find out this PA also, like we have done for previous things, cohesionless style, okay, that's what it is given. So this is trial weights method, okay, it's not given in our syllabus. So with that we have finished our second chapter, and you just go through this a very simple chapter where we have discussed Rankine's earth pressure theory, okay, and Coulomb's earth pressure theory. Once you are confident with the vertical forces at a depth z, we can find out the horizontal forces by multiplying it with the K naught, Ka, and Kp. Okay, K naught at pressure at rest, Ka is active earth pressure, and Kp is the passive earth pressure. Okay, so and this Ka, K naught, Ka, Kp, Terzag is sorry, uh, Rankines give in a different way, Coulombs given in a different way. In the graphical methods, okay, has given for it depends on the inclined surface backfill, and it depends on the uh, whether the wall is vertical or inclined with I angle or beta, okay. So those big formulas no need to remember, okay, but at least Rankine's earth pressure theories, some formulas, okay, Coulomb's also, you try to remember few because it is useful for gate also. So and question paper would be generally logical, and we have solved the numerical also in this chapter, okay. So those numericals also very very important. And in this particular chapter, as I said, tension crack and unsupported height and all the earth pressures are important in this particular chapter, okay, for your competitive exam. Tension cracks, unsupported height, cohesive soil, how it would be on the top it would be negative, and at the bottom it would be positive, and find out the z value, okay, this is very very important, so for preparing for your competitive exams. So with that, what I'll do is I'll stop today. uh, I'm downloading attendance. So, so anyway, as you suggested, we'll have our uh, exam on 9th morning then. Is that clear?